So these are metamorphic rocks, and you can see my daughter in the background. Say hi. Metamorphic rocks are when rocks are changed directly. They come from some other rock, and it's because of heat and pressure. Just heat or heat and pressure, either one of those things can change a rock into something else. And metamorphism, if you think of metamorphism from butterflies, just got to flip back here to the chart that I had, this chart right here. You can see here that metamorphic rocks came from igneous rocks, or they come from sedimentary rocks, or they come from another metamorphic rock. And it's just heat and pressure that causes that change, that metamorphism, to make them into a new rock. So the changes that happen in metamorphic rocks, the crystals get they can be recrystallized of material that was not melted, and this is the key. The rocks don't remelt. If they remelt, then they're an igneous rock, right? So the density, because of the pressure that's pushing down either from above or from the sides, causes the molecules to get closer together. And when the molecules are closer together, they get more dense. Foliation is when the minerals get lined up, and you can sort of see that with this rock right here. These are the minerals bands, and they're lined up together. And that banding are these alternating bands of crystal. And so as you can see, we're back to here, but as you can see, the pressure on rocks, if this is an igneous rock with all these crystals in just random order, they're just all intergrown together, but there's no pattern to them. When there's pressure pushing down, in this case it would be from above or below, the minerals tend to line up. The crystals tend to line up in layers, and I'll show you an example of that in class. Again, pressure here coming from the sides causes these to line up and to segregate into distinct bands. And that's one of the characteristics of metamorphic rocks, is that they have these bands of minerals. Now, that happens because as two plates come together, the tremendous amount of pressure, and because these get buried deep underground, the heat that's causes them to change. They don't remelt, they just change in here, and that's what causes these bands to get distorted. And you can see that right in this rock right here. There's one of those rock hammers, and you can see that these are those bands of minerals. They get distorted because there was pressure pushing down, and we can see which direction the pressure was coming from, because it was coming from top and bottom here, and it causes these to almost act like that silly putty that I've shown you in class, where it flows like a plastic, or it starts to move and gets to slide. The crystals slide along one another, the layers do, but it never remelts. That's the key. So we have two different kinds of metamorphic change. There's regional metamorphism, where we have very large areas, like two continental plates colliding, and they're under a lot of pressure, a lot of heat, and that is where you get these mountain building events. So underneath the Himalayas in India and China, the border there, you would have this sort of metamorphic change happening right now. But this takes thousands and millions of years to occur. They're very slow changes over long periods of time. Contact metamorphism, on the other hand, can happen a little bit more quickly. It's when molten rock comes in contact with surrounding rock. So the heat itself is just altering the rock. It's not necessarily a pressure that's causing that change. So this we can use to help us find the age of rocks, and I'll talk about that in a minute, and maybe a little bit later when we talk about the age of rocks and how we find the age of rock layers. But what you'll see is, if this was an intrusion or an extrusion, as this molten rock was rising, wherever it touches another rock, that's where you'll get that contact metamorphism. The reason it's called contact is because you have molten rock sliding along. Whatever rock it touches, this rock will change because of that intense heat from that molten rock. And that changed rock is a metamorphic rock. It may not be a very big band of it. It may just be in where that contact zone is, but it still can be a metamorphic change, a metamorphic rock. So that happens when you have molten rock pushing through magma, pushing through into other layers, and these intrusions happen where there's cracks in the rocks. So you might get a fault, and then you'll get molten rock pushing up through those faults, those cracks, and that causes these intrusions, and you'll get contact metamorphism right along the edge of those intrusions. Now, if it was an area where it extruded onto the surface, it was on the surface here, then you would only have contact metamorphism with the area that was there before that extrusion. So it would just be the top layer that would have that contact metamorphism, along with any of the area that was in that intrusion as well. So this is one of the ways that we can tell. So if this is igneous rock, basalt, as we remember from the igneous rock chart, this, you can see there's the slash marks, those hash marks there, are where the contact metamorphism happened. So this molten rock came out onto the surface, and we know it's with basalt, it's small crystals. So it flowed out onto the surface, had contact metamorphism with this sandstone, but the shale was not there yet. And we know that because there's no contact metamorphism. You can't have this basalt move into a layer, have contact metamorphism here, but no contact metamorphism here if this rock is there. This rock wasn't here when the basalt flowed out. So that's how we can know that. So here we can see that the limestone and sandstone were formed, then this molten rock came up, pushed through, and then that melted. Some of these were not melted, and it shouldn't say melted, it just changed. And the rocks it touched during that change, due to extreme heat from the magma, became metamorphic rock. So it might have melted some of this rock and been included in this basalt, and then that stuff that did not melt over here on the edge is considered metamorphic rock. Okay. So we just describe these rocks as we classify them by their texture and their composition and the amount of metamorphic change there is. So the degree of metamorphism also helps us. So you can have a little bit of metamorphic change or a lot, depending on whether you have contact metamorphism or if you have this regional metamorphism over millions of years. It can cause the changes to happen have more change. So this chart is on your reference table, page 7, and you can see that we break these rocks down into two groups. What is that? So we can see that the chart is broken into two groups: foliated, the ones that have mineral alignment, where the pressure caused the layers of crystals, and non-foliated, which just don't have those bands or layers. The type of metamorphism kind of matters, whether it's regional metamorphism. These all have, as you increase your heat and pressure, it changes from slate to phyllite to schist to gneiss. Slate came from shale, so a sedimentary rock shale turns into, when you put a little bit of pressure on it, turns into slate. Slate then will turn into this stuff called phyllite. A little bit more heat and pressure causes schist to form, and then a little bit more heat and pressure causes something called gneiss. And I'll show you examples of those in class. The non-foliated are really, we decide those based on their composition, what they're made out of. And we can see that quartz makes up quartzite, calcite makes up marble. And again, here's that test. We can test for calcite with that acid test. So you can find out whether it's marble or quartzite based on whether it bubbles with acid. And then you have metaconglomerate, which is basically just conglomerate metamorphosed. So that gives us sort of our breakdown. The deeper underground you go, the more metamorphic change you'll have happen. So you go from slate, that turns into phyllite, then schist, and then gneiss. So this is the parent rock of this. And I think that's it. That's it. So we're going to spend some time in class with this chart and working with the chart. So if it's a little bit confusing, I understand that, and we will get you some practice with that. So for now, goodbye. You want to say goodbye? You want to say a joke? No? Not even your mittens joke? All right.